We are solving one question from chapter of sound when a man moving towards a cliff. So let's say if this is the cliff, okay, if this is the cliff, okay, then the man is standing over here, let's say over here, okay, this is the position of man, okay, this is the initial condition as given into the question, okay. So the man moving towards the cliff, so this man is just moving towards the cliff in this way, right? This man is moving towards the cliff, okay. So the movement will be towards the cliff, right? Now what is given, and the movement is given as u meter per second. So the velocity, you can see the velocity of the man is given as u meter per second. This is the data given to you, right? This is u meter per second, right? U. Now it hears echo after t seconds. It hears echo after t seconds. When firing done, he was d meter from the cliff, okay. So basically the actually firing done when you are d meter from the cliff, he hears the echo. So when the firing is done, if this is the, if this is the, let's say from a gun, if this firing is done, then the sound will be, what will be the position of sound, okay. The gun will be, the bullet will be going like this, okay. The sound and the traveling is done by sound, okay. So this is the path of the sound which is initiated, right? So the sound will be traveling from A to B, A to B, the sound will be traveling, okay, and it strikes the cliff, then it starts its return journey. Then it starts its return journey. So the echo will be generated at this point after striking the cliff, and this will be the sound direction. This will be the sound direction. Let's say when it reaches to point D, when the man is coming from this direction, left side, and it also reaches to point D, and the sound was also traveling, and after striking the cliff, here the echo is generated, and the echo was heard at point D, okay. Then you can see from this position to this position the man traveled, okay. So firing is done at this point. Firing is done at this point, right? Firing is done at this point. So that's why the sound is traveling, started traveling in this direction. You can see in this direction towards the cliff, right? So when sound started traveling, man didn't stop. He also kept on traveling like this, right? He kept on traveling. When, but during the journey of sound, it goes from A to B, strikes this cliff, and after striking, it rebound. Okay, the sound is reverted back. Okay, this is the point where echo is generated. Let's say this is also B dot or B. From B to D, this is the red line where the echo is generated, and echo is travel. The path of the sound after generation of echo, right? Now the man speed is u meter per second, and here the man heard the echo after t second of time, you can see. So the time taken by the man to hear the echo is t seconds, right? So let's say if the total, let's say the total distance covered by the sound, if this is A to B, if this is D, right? And from man position, that is A to D, let's say this is also A, this is X, this is X, and this is D. Then the total distance covered by the sound, total distance covered by sound is how much? Tell me. Definitely it's from A to B, then B to D. This is also B because these are on the same line. Then B to D, right? So the total distance covered is A to B, that is equal to D. Here you can see, because the firing done when he was D meter from the cliff. So that's why D meter is the point, is the distance AB. The length of distance AB is D. So the value of AB is kept as D, and the length of BD, this one, BD is calculated when AB is D, AD is X, we have assumed it, then AB minus AD. So AB is D and AD is X. So D minus X is the length of BD. This is D minus X, and this is the length of BD. This will be D minus X, isn't it? This will be D minus X. Now, the total distance covered by sound is D plus D minus X, right? So, we can calculate the velocity of sound. So, the velocity of sound which we need to calculate is given by what? Distance covered, that is D plus D minus X. That means 2D minus X is the distance covered divided by the time taken, T. You can see T divided by time taken, T. This meter per second is the velocity of sound, but here X is a variable. We need to replace the value of X. So this can be written as 2D by T minus X by T, right? But X by T, X is the distance traveled by man, and T in T time, and you can relate this with U, because distance by time is the velocity, and the man moving towards cliff at the rate U meter per second. So this value X by T is gives you the velocity of man. So this will be 2D by T minus this one, which is equal to X by 2U. T is U. Yeah, this is the velocity of man during walking. You can see over here it's given U, right? So this is your answer, 2D by T minus U meter per second, right? This is the velocity of sound. Velocity of sound, right? So in this way we have solved these questions. 2D by T minus U is the velocity of sound which is calculated. This one, 2D by T minus U meter per second. This one. Thank you so much for watching, students. Any query you can just put up into the comment box, into the chat. Should I explain it again? So the man was moving towards the cliff, fires gun. Man was moving at the rate of u meter per second and hears echo after t seconds. Firing done when he was d meter from the cliff. Okay, we need to find the velocity of sound. A to B is the distance. Okay, because it was fired when he was done. When the man was at d meter from the cliff. So AB is the distance d, right? Now the total distance covered by the sound is d, this one, plus d minus x, right? This will give you 2d minus x by t, right? This will give you 2d minus x, and the velocity of the sound is total distance by total time. Okay, so the time taken was t, so 2d minus x by t, so this will give you 2d by t minus x by t, and x by t is the velocity of man, which is given to you as u meter per second. So in place of x by t, you replace it by u, right? So this will give you 2d by t minus u. This is the velocity of sound which we have calculated in meter per second, right? Thank you so much for watching, students. Thank you. Bye bye. Take care.